For the following exercises, sketch a graph of the piecewise function. Write the domain in interval notation. All right, so just remember, guys, down here, a piecewise function is a function that's just defined by two or more formulas over a certain domain, or aka set of x values. So if we notice in the first problem, right, here is the first formula, and this is the domain of that first formula. Here's the second formula, and this is the domain of that second formula. All right. And then we'll ask, once we plot this whole thing, can we find the domain of the whole thing? And we should be able to, no problem. All right. So first, piecewise functions look confusing, but don't get lost with all the stuff all over the place. Focus on one part at a time. So let's first focus on this formula with its corresponding domain. So the formula they're telling us is going to be f of x is equal to x squared. Now, instead of f of x, I'm just going to use the term y, okay? So y is equal to x squared. Now, y is equal to x squared only when, they use the term if, right? Only when x is less than 0. So that's fine. What I want to do is try to sketch the graph here. So first what I want to do is actually plug in the value of 0 into x here. All right, so that I can find out what y would be equal to if it could be equal to it. So 0 squared is obviously just 0. So when x is 0, it tells us that y is also 0. So on your graph, go to the origin and plug in an open circle there. Don't close it, all right? Don't fill the circle. This term right here, this less than term is just less than. It's not less than or equal to. All right, so you use an open circle. I wrote some notes down here for you guys. The next thing we're going to do is now we're going to plug in whatever values we like for x. However, it has to follow, right, this general condition that x has to be less than 0. So why don't we do an easy one? Let's plug in -1. Make sure you put this in parentheses, please. Otherwise, it will work out to be wrong. So when you square -1, obviously it becomes 1. So when x is -1, y is indeed 1. Where's that located on the graph? Well, that's located right here, right? Over to the left 1 and up 1. Okay, easy enough. Let's choose another set. Oh, excuse me, let's choose another value. Why don't we choose -2? When you plug that in, what do we get? Y is equal to now 4. So when x is -2, y is 4. Let's plug that in. So that looks like it's going to be about here, right? And I can keep going, but notice it is not linear, all right? You can notice that by the shape of the graph now, but you can also tell that from the function itself. It's a quadratic, right? So it's going to have this parabolic shape to it. So why don't we just draw this on in something like, it's going to look something like this, okay? Something like that. So I'm going to draw my arrow now because it's going to keep on going forever on the left-hand side, all right? So I took care of the first part. I took care of the first part of my piecewise function. Now let's take care of the second piece. So here's the second piece, new formula with a new restriction on it. So let's write the formula out. So y is equal to 1 minus x. Now I'm going to use the value that they're giving me. I know that it's not an equal to, but I'm still going to use 0 to find where I should put my open circle. All right, so let's plug in the 0 for x. So y will be equal to 1 minus 0. Obviously, this is 1. Okay, now when x is 0, y is 1. Where is that located on the graph? That's located right at this particular point, okay? Do, though, an open circle here. Do an open circle. Let me try to make that a little better. There, okay? Don't close it because it's not, technically it's not equal to. It says greater than, not greater than or equal to. Now, let's choose another value for x in my function here, okay? But remember, we still have to follow the condition that x here has to be greater than 0. So whatever number you like that satisfies that. I'm going to choose 1, make it easy. So 1 minus 1, y is going to be 0. So when x is 1, y is 0. Where's that located? That's located right here. We can do this again, right? Why don't we choose a value here of now 2? All right, 2, this will be -1. Where's that located? That's located right here now, etc. I think you see the picture. So this is now a nice linear line, right? We'll draw it straight down, and that should be pretty good. Okay, it's going to continue on forever. So this is what the piecewise function looks like, all right? Looks like a bunch of pieces thrown together. Now we have to figure out the domain of this thing. Now remember, the domain is the set of x values. I like to say range, but it confuses me too, but Don't want to confuse the terms range and domain, or use the word range with domain, but it's the set of x values, all right, that this particular function can obtain. So if you notice, are there any x values that it cannot obtain? Well, we have an issue going on right here, where neither parts of this piecewise function, the red part or the blue part, has 0 filled in. That's a problem, right? That's a restriction on the domain. In terms of then the blue graph, it's going to stop at less than 0, and it's going to continue out forever, right? Moving towards negative infinity over time. So I know that the domain here for the blue part is going to be all the way from negative infinity, exclusive of it, because you can't include infinity. It's not a real number. And then it goes all the way to 0, exclusive of it. So that's the first part of the domain. Okay. Now let me just actually make this a little smaller. All right, just so I can fit it on here. So this is going to be from negative infinity all the way to 0, exclusive. Or you could have been on the red line. And the red line now will be from 0, exclusive of it. So that's why it's a parenthesis, all the way on out now to positive infinity. Okay, so we're going to write positive infinity. And here is your domain in interval notation. Moving on to the next one. All right, let's run through this one. Let's see. Okay, so ready? Same thing. New function. Here's the first condition. Let's not think about this too much. It's literally the same as this. Okay, so that's actually kind of nice, right? So when we graph this thing, I'm not gonna. You can go through all the steps again, but we just basically did it. So let's plug in these numbers, right? So when we got 1, 2, 3, and then we got 4, 1, 2, 3, 4, and then x is going to be 2, etc. And now we plug in our nice little curve here. Oh, 1 second. My curve is, that's close enough, hopefully. That looks good, reasonable. And that's the first component, all right? And now the second part is going to be slightly different, right? Same general concept, but two things are different. If we notice, it's a greater than or equal to, and the equation changed, but that's not a big deal. So let's write the equation on out. So we got y is equal to x plus 2. Let's use the value they gave us, plug it in for x here. All right, let's find what point we're working with. So we got 0 plus 2, so y is equal to 2. So when x is 0, y is 2. Where is that located? It's located right here at that point. Now this, you fill it in. Why? Because when you're at 0, it includes 0. It's equal to at that point. All right, and I wrote you some notes down here that you can write down and kind of remember. So that takes care of that. Great. Why don't we do the next point? Whatever point you want. I'm going to choose 1. Right, I got to satisfy this domain that x is greater than or equal to 0. So 1 satisfies it. I'm going to plug that in. What do I get? I get a value of 3. So this tells me when x is 1, y is indeed 3. So that looks like it's going to be right here. Okay, and we probably are going to notice a pattern, right? We can keep on going. No need to, though. It's a linear graph. I know it's going to be a straight line. It's going to go through these points nicely, and there we go. Okay, so here's that part. Now, that takes care of the piecewise function. Now, when we have to state the domain, right, we have to think about what are the limitations or the restrictions on x. Well, this part we said can go all the way on out eventually over time to negative infinity. We also know that this rightmost part can go all the way on out to positive infinity. What about, though, this part in the middle, meaning at 0? Well, don't get too bogged down with this. As long as one of the graphs has 0 filled in, that means that 0 is indeed part of the domain. So although it's not filled in here, it is filled in for the second formula. And therefore 0 is part of the domain. So it's nothing special. This one literally goes the domain from negative infinity all the way to positive infinity. Use the brackets because that means it's exclusive, right, of those values. And there you go. Guys, thank you so much for tuning in. I really appreciate it very much. I hope this video helped you. And if it did, hit the like button. All right? Take care.